Hi, welcome to this introduction to video summarization. Have you ever wondered how sports sites can generate match highlights so quickly, with each different match highlight consisting of exactly the same build-up? Well, the answer to this question is video summarization. But what is video summarization? Video summarization is a technique that extracts prominent information from the video and generates a summary in the form of key frames or key shots. The purpose of video summarization is to analyze a video and drop the redundant frames while retaining its key frames. Moreover, it helps to accelerate the browsing of an extensive collection of video data and achieve structured access and representation of the video content. You may be wondering why we need video summarization. As technology continues to advance more rapidly than ever, the amount of video data being generated on a daily basis is reaching unprecedented levels. However, processing and storing such massive amounts of video requires significant storage space, computational processing power, and time. Furthermore, video traffic continues to grow and to become the dominant form of internet traffic. With so much video content available online, it's essential to have ways to quickly find and view the most relevant parts of a video. Video summarization enables users to get a quick overview of a video's content and decide whether it's worth watching in full. This is especially important for mobile users who may be limited by data plans or slow connections, or for those who simply don't have the time to watch a full-length video. The general procedure of video summarization consists of 4 steps. First, video, audio, and movement are extracted in the pre-processing step. Secondly, the features are analyzed and processed to extract meaningful information. After that, the summary is made based on techniques that will be discussed later on. Finally, the original video and summary are used as input and metrics are used to measure the accuracy of the summary. The main question now is, how does this technology work? Video summarization can be done using multiple techniques, each with their applications, pros and cons. The main techniques can be bundled into 5 categories, namely, based on features, based on trajectories, based on clustering, based on shot boundaries, and sparse dictionary learning. Let's now dive a bit deeper into each of them. The first category of techniques uses video features to create a summary. As videos contain objects, events, color, and motion, these features are crucial for spectators to quickly understand the content of a video. Event-based summarization can be done by calculating the energy of each frame. The energy of a frame is defined by taking the sum of the absolute difference between the current frame and the reference frame pixel values. By doing this, the presence of an event can be identified. Another method is multi-view event summarization. This method compares video sequences and groups them. After that, less important events are removed with the help of object tracking and the summary is generated. This kind of summarization performs better when the background is static. In case of dynamic backgrounds, this technique has its limits. Motion and color-based video summarization make use of color histograms. The first frame in each shot is selected as key frame, and the color histogram is used for the identification of further key frames that are combined to extract the summary. This method is especially useful for videos where the motion level is moderate. Just as event-based summarization, it has its limits, namely for videos without motion or videos with a lot of motion. To conclude this technique, it can be seen as simple but having a low accuracy. As the name says, object-based techniques try to detect objects in videos. All frames with a desired object are collected for this method. This causes problems when the desired object is not in the video. Initially, a hierarchical hidden Markov model identifies motion features and then semantically categorizes the low-level features to a high level, and that features of the object are identified to generate a video summary by selecting the most representative frame from the video. A drawback of this method is that it tends to miss objects. The last feature-based technique is called attention-based video summarization. The models used in this technique identify the user's interests. For each key frame or shot, a score will be assigned corresponding with the interest of the user. This is done based on quality, color, hue, and attention. The high-scoring frames will then of course be used in the summary. The second category, clustering-based video summarization, tries to identify similar activities or properties within a frame. Common or specific activities which exist in different scenes of a video are the subject of similar activities clustering. This is done by extracting features of activities that occur in multiple frames. By comparing these, similarities or irregular patterns can be found and filtered. This method is sensitive to false predictions, which can lead to wrong summaries. K-means clustering uses the K-means algorithm together with a histogram. The frames of the video are gathered into a histogram. Using the information from the histogram, the video is partitioned into K clusters, whereas the first frame of each cluster is considered as representative. The required segments can now be collected into the form of a video summary. This approach is suitable for dynamic scenes but not for static scenes, since static scenes are too redundant. The last example of a clustering-based technique is called spectral clustering. Spectral clustering is a grouping technique for similar data points based on their relationships by constructing a similarity matrix. When applying this theory on the video summarization problem, similar events can be clustered and then be used to create a summary of the video. This approach is particularly useful for videos with long durations or complex content, as it allows us to quickly identify the most important or relevant parts of the video without having to manually review the entire footage. Shot-based video summarization techniques divide the video into shots, which are continuous segments of footage, and use keyframes from each shot to create a summary. The deviation can be done by many ways, for example the first frame of each shot or selecting frames with high visual diversity. This approach is useful for videos with distinct shot boundaries and a limited number of shots. Trajectory-based video summarization techniques track the motion of objects or people in the video, and use their trajectories to identify important events or actions. These trajectories can be obtained using object tracking algorithms, and can be used to identify activities such as walking or running. This method is particularly effective for videos with a lot of motion and activity, such as sports events or crowded public spaces. Sparse dictionary learning is a machine learning technique that learns a sparse representation of the video frames. Sparse representations are representations that only contain the most important information. This allows us to identify the most informative frames that capture the essence of the video. This approach is particularly useful for videos with complex content and a lot of variation in visual appearance. Let's tell a bit more about the deep learning architectures being used now. There are two main approaches to video summarization: supervised learning, which uses labeled data, and unsupervised learning, which does not use labeled data. The former is easier but is expensive, while the latter seems to be gaining more traction. Let's illustrate the most prevalent architectures. Generative adversarial networks use two neural networks. One of those generates a text summary and then reconstructs a video based on this summary. The second network compares the original video with the generated video and determines if it is similar or not. This has shown really good results on unsupervised learning. Secondly, there is reinforcement learning. This approach uses a reward function in order to prioritize the desired outcome. It does not require labeled data, but it does require the tailored reward function for each task. This is also known as weakly supervised learning and is often used in sports and events. Long short-term memory figures out the temporal dependency among video frames, and determines if a frame is valuable by taking into consideration the frames that have been selected already. This approach has been promising because it maintains a coherent storyline in the video summary. Video summarization is already prominent in your day-to-day life. It's used in video surveillance to extract only the important events. News sites use it to provide bite-sized clips of their news reports. Trailers can even be automatically generated for movies. In the sports industry, summarization can pick out when a team scores. To conclude, it can be said that video summarization is complex. It is difficult to determine which parts of a video are important, and the preferences of the end user might not align with what the algorithm outputs. For example, a user might want a 10-second video, but the algorithm returns a 2-minute one, because it considers that it's the only good representative summary. The fast advances of deep learning in this decade have enabled the increase in precision and quality of video summarization. Furthermore, the ever-increasing video content that is produced every day is one of the driving forces of innovation in this field. And as showcased, There are multiple approaches to the problem, and it is interesting to see that each one of them might become at some point one of the leaders.